Hi, welcome to another episode. In this video, we are going to look at link aggregations with EtherChannel. So why link aggregations? You want to do aggregation of links in a switch network in order to have higher bandwidth. So if you look at this topology, we have three switches. The distribution switch connecting to two access switches. We call this access switch number 1 and access switch number 2. So here you have two fast Ethernet links connecting between these two switches. That's 100 Mbps each. So you don't want STP to disable one of the links or block it. As you can observe here, one of the links is marking orange. So that means so one of the links is blocked by STP to prevent a layer 2 loop happening in your network. So you want to make use of both of these two links. That means putting them together with a 200 Mbps capacity instead of having one being used at a time. That is to make sure if one physical link is not available, the other one will be used to forward traffic. Likewise, you can do the same thing on the other side. One of the other reasons to have link aggregation is fault tolerance. So, for example, if you bundle these two physical links together and they will appear as one logical link. So, the fault tolerance there is if one physical link is not available, still now one physical link will be used in the logical bundle to forward traffic. Okay, so EtherChannel is one of the technologies that you can use to do that aggregation for you. So if we go into the switches right now, if I go into this aggregation, this access switch, I can display spanning tree. You can see that SDP is currently happening, and first it is 0/1 and 0/2, which are our uplink connecting to the other switches are on designated mode. So, and it's telling us this bridge is the root, so that is why we have both of these two ports on designated or forwarding mode. So if I jump right into the distribution switch and display the spanning tree status there, we will see that some of the links will be on block mode. So you can see FA0/2, which is one of the physical links connecting to the access switch number 1 here, is on block mode. So that means that port state will not forward any traffic that is passing through that link. So you want to make sure that this blocking is not happening. So all of these ports will be utilized by distribution switch, that is both port FA0/1 and 2, to send traffic to the access switch number 1. Likewise, it's also utilized the other ports sending traffic to access switch number 2. So if you observe here as well in access switch number 2, you can see that this Gigabit0/2 also is blocked by SDP. Okay, so let's display the spanning tree status there, and we can see that GA0/2 is on block mode by SDP. So let's see how we can aggregate these physical links and make use of both the physical links and the switch connection instead of one physical link. So know that EtherChannel, you can bundle as much as 8 interfaces, but these interfaces has to be similar interface. That means if you are bundling interface, it has to be the same interface type, that is either fast Ethernet or gigabit Ethernet type. So there are different type of EtherChannel modes. We have the PAgP and then the LAcP. Okay, LAcP is the industrial standard, whereas the PAgP is Cisco proprietary, so that means it can only be enabled on Cisco devices. LAcP is link aggregation control protocol, okay, and it has different states. So state 1 is when the channel mode is on, that means the channel member is formed with EtherChannel without negotiations. So if the channel mode is active, so that means the interfaces will be actively asking for the other side to participate and to form EtherChannel. So if the channel mode is passive, so that means this interface will be passively waiting for other side to initiate the formation of EtherChannel. So if you are bundling interfaces between two switches, so the combinations has to be correct for EtherChannel to be formed. For example, here we have, if you have switch 1 and switch 2 here, if one side is on, that means if the EtherChannel side of one switch is on, the other side of the other switch is on, so they are going to form an EtherChannel. So if one side is also active and then the other side of the other switch is active, they also form. Or one side is active, passive, the other side is passive, they also form. But there are some combinations that will not form EtherChannel. For example, if you have one switch has an EtherChannel mode of on and the other side active, in the LAcP mode, this EtherChannel will not be formed. Likewise, for PAgP, which is Cisco proprietary, PAgP also has these different modes, and it is on, desirable, and auto. So also you might want to have combination that will form EtherChannel. That is when one side is on and the other side is on, and when one side is desirable, the other side is desirable. So EtherChannel will be formed. But if one side is on and then the other side is desirable, so no EtherChannel will be formed. So you want to make sure that in your configurations you ensure you choose combination that will form EtherChannel. Okay, to start with access switch 1, so we configure these two physical interfaces, that is FA0/1 and 2, which are to be bundled to form a logical interface. We go to global configuration mode and we interface range FA0/1 or to 2. Just sort it down. So normally I sort this interface down, do the EtherChannel configuration, and later bring them back up. Most of the time will give more success. Okay, so channel group 1 mode desirable. So interface port channel 1, switch port mode trunk. Okay, so EtherChannel has been configured for these two physical interface, and they are part of channel group 1. So that means a logical port will be formed, and now these two physical interfaces are both part of this logical interface. So you can say, so EtherChannel summary, and now we can see that port channel 1, that means the logical interface is now formed, which is bundling for fast Ethernet 0/1 physical interface and fast Ethernet 0/2 physical interfaces. So both of these two physical interfaces are now part of this logical interface, and the protocol that is used is PAgP. So the S flag code is showing us it's a layer 2 interface, and the D is showing us that it is currently down. So we want to make sure that we see SU. So that means layer 2 interface EtherChannel plus U means if it is in use and is in upstate. So because we haven't configured the other sides of the link, so that means the other side of the switch distribution switch end. So we go there and do the configuration there. Global configuration mode, interface range FA0/1 to 2. We sort it down. Channel group 1 mode desirable. Go to interface port channel 1. Here, because it's a distribution switch and the switch are of different versions, so there will be some little bit configuration difference here. So we do the encapsulation first. Switch port trunk encapsulation .1Q switch port mode trunk. Because if we step back a little bit, we can see that the version of the switches are different. Like here, you can see this is a Cisco 3560 switch, and this access switch is Cisco 2960. Cisco 2960. So that's why we have some little bit command difference there. So now I am done with EtherChannel configurations. So let's go and enable the interfaces back up. And also enable the other sides. Shut down command. Now we should expect to see EtherChannel form. So EtherChannel summary. Good. So here we can see our port channel 1 is up and running. So that means EtherChannel is working now for both of these two switches. So here, if you come to the distribution switch and also display this EtherChannel, so EtherChannel summary, we can see that the EtherChannel link is up, and we display spanning 3. We can see that also spanning 3 is functioning on the logical interface. Okay, so the next thing is we configure LAcP on the other side, that's between the distribution switch and access switch number 2. So we start with the distribution switch. to go to global configuration modes, interface range G0/1 to 2. So because this link here is gigabit, it's different from the other one which is using fast Ethernet. We sort it down first and say channel group 2 because I already used channel group 1. So here I'm going to use channel group number 2, and I say mode is active. So for LAcP, we use active on both sides. Okay, and we go to the port channel interface, port channel 2. We say switch port trunk encapsulation .1Q, switch port mode trunk. Okay, so we're done there. We go to switch the access switch number 2, enable EtherChannel interface range FA0/1, sorry, G0/1 to 2. Shut down. Channel group 2 mode is active. Port channel 2, switch port mode trunk. Enable interfaces range G0/1 to 2. No shutdown. On the other side, that's on the distribution side, interface range to enable the interfaces G0/1 to 2. No shutdown. Okay, so now if you observe the EtherChannel again, you should see EtherChannel also form on a second port. So this is logical port 2. PO2 is also up and it's running, and this is operating with a LAcP, okay, on the gigabit 0/1 and gigabit 0/2. So now if you observe the topology, we don't see any orange. That means packet tracer is showing us that STP is not blocking any port. So basically we are making use of all physical connection or the physical links capacity. So here we have a total of 2 GB because we have 1 GB interfaces, and here we have a total of 200 MB because we have 2 fast Ethernet interfaces. And if you display STP, you will see that spanning tree will now be working on the logical interfaces. For example, we say spanning tree VLAN 72. You can see that STP is now making use of the logical links or the logical bundle instead of the physical interfaces. So that means the full capacity of these physical interfaces will be used. So we can test our ping from our one PC, that's PC1 to PC2, ping 172.72.1.11. So our ping is responding fine, and traffic will be forwarded using the logical link. So that's it for EtherChannel link aggregations. So if you enjoyed this video, subscribe, and I will see you next time. Thanks for watching.